today I'm going to cover 13.4 notes, day 1. You're going to need your own paper. And actually this entire week when I'm teaching, you will need your own paper. So if you need to, pause the video and get 1 or 2 sheets of paper. You're welcome to use the scrap paper in the front of the room on my bookshelf if you don't have any paper. Alright, so now that you have paper, 13.4, we are going to talk about graphing the sine function. So we have looked at evaluating sine, like sine of 30 degrees, sine of 135 degrees, sine 360 degrees. Now what we're going to do is we're going to piece together the unit circle so that we can actually graph the sine function. So I want you to recall when we had the unit circle. The unit circle means that you have a radius of 1 unit. So I'm going to go around and do my 4 main points. Because I'm putting this unit circle on a coordinate grid. Okay, so the left is negative, the down is negative, the up is positive, and the right is positive. So look again, and I've got 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now what this relates to is at 1, 0, that's at 0 degrees. 0, 1 is at 90 degrees. Negative 1, 0 is at 180 degrees. 0, negative 1 is 270 degrees. And a full rotation at 360 degrees is still at 1, 0. So I want you to also remember what we learned is every x, y was equal to cosine theta, sine theta. So for example, the point 1, 0 is equal to the cosine of 0 degrees, the sine of 0 degrees. So let's think about this. If I go around the circle, the sine of 0 degrees, that's the y-coordinate. Okay, this is the y-coordinate. So that's 0. The sine of 90 degrees is 1. The sine of 180 degrees is 0. The sine of 270 degrees is negative 1. And all the way back around, the sine of 360 is 0. So I want you to pause the video and I want you to think. I want you to look at these values and make sure you understand why is sine 0 degrees equal to 0? Why is the sine of 90 degrees equal to 1? Why is the sine of 180 degrees equal to 0? And so on. All right, now what I'm going to do is I'm going to take and look at this as if it's x and y's now, but with 0 degrees has an output of 0. If I put in 90 degrees, it's a 1. 180 degrees is 0. 270 degrees is negative 1. And 360 degrees is 0. So what if I want to plot these points? So what I'm going to do, it's a little bit different when you're graphing trig functions. We don't usually go up as high and low on the y-axis as we did in a regular coordinate grid. So I'm going to make tick marks, but it's going to go 90 degrees, 180, 270, 360. And I'm going to go up one and down one on the y-axis. So let's plot. These are referred to as the 5 main points. Okay, these 5, and we got these 5 from the unit circle, going around the circle. So if I plot, here's 0, 0, 90 degrees is up 1, 180 degrees is 0, 270 is down at -1, 360 is 0. So you're going to plot these 5 main points. Now what's neat is that they repeat, repeat, repeat. And if you remember the beginning of our chapter, we talked about periodic functions. So if I go ahead and continue 4 ticks to the left so that it goes to -360, and this one's -180. If I continue the pattern, because sine functions are periodic, the period length for the sine function, it takes 360 degrees. Okay, remember, the period length is how long on the x-axis does it take to repeat. And something else we talked about previously was amplitude. Well, amplitude is half the distance from your maximum minus your minimum. So half of 2, my amplitude is 1. So the sine curve oscillates forever, which means the domain is all real numbers, or -infinity to infinity. The range, now you remember how when we learn a new function, so we did quadratic functions, we did absolute value functions, we did square root functions, and then we did logarithmic functions, exponential functions, and we talk about domain and range. But the original graph that you start with is referred to as the parent function. So y equals sine x, or y equals sine theta, is the parent function. So the range of the parent function is -1 to 1. It is brackets because it's touching 1 and -1. So let me state that. The parent function is y equals, you can call it sine x or sine theta. It really is an angle that we're doing. If you need to, pause the video and watch any part of this opening discovery to, again, to just maybe hear it a second time. If you watch it the first time and it doesn't make sense, it is really, really important you rewind it and watch that part again. Because when you're first writing this down as I'm talking, you're so busy writing that you're not able to comprehend what I'm saying. So sometimes going through it once and getting everything written down, then go back and look at your notes and then hear what I'm saying. Then more will go in. So I really, if you're at all confused about what I just went over, pause the video, go back and watch it again. And just allow your mind to take it all in. All right, so let's write the general form. If I have y equals a sine x, the absolute value of A, and it does have to be absolute value, is the amplitude. So, for example, if I give you y equals 2 sine x, my amplitude is the absolute value of 2. Up to this point, the period is going to be 360 degrees. We are going to see how that gets adjusted, but for right now, it takes 360 degrees. All right, now I'm going to give you 2, and I want you to tell me the amplitude and the period. Pause the video after you have tried them. Okay, please pause the video and try it. So in this one, the amplitude, absolute value of 5 is 5, and the period is 360 degrees. On this one, the amplitude is not -4, okay? It's the absolute value. And I'm going to graph 2 of these for you so you can see how this works. So let's go back to mine. My y equals 2 sine x. When you put a number in front, watch this. I'm still going to use my 5 main angle measures until we figure out when the period changes. But for now, we're going to start 0 degrees, 90 degrees, 180, 270, 360. And what you're going to have to do is, let's go back, and you remember how the sine curve starts at 0, 0. And then if you look at this table, this is going to be a critical thing that you need to just start remembering. You can always go back to the unit circle to create it, but sine starts at 0, 0. So that's important. Sine starts at the origin. It goes 0, 1, 0, -1, 0. So if I look at this one, it's going to still be 0, but when I take 2 times the 1, this becomes 2. This one's 2 times 0. 2 times -1 is -2, and 2 times 0. So watch this. This is really interesting. And we typically do 2 period lengths. And I make 4 ticks, and you can, because you're scrunching a little bit, I label every other tick. I do want to mention, as you're getting your grid drawn, the period length is not always 360. For what we're doing right now, it is, and I will show you in a little bit how it changes. Now, my y values have changed. I go 0, 0, then it went up to 2, 0, and then back to -2 and 0. So this one is taller. We stretch. Then all I do is I continue the pattern on the left side. So now, can you see why the amplitude is in fact +2? You do 1/2 the maximum minus the minimum. Half of 4 is 2. All right, let's do this one over here. The y equals -4 sine x. So I go 0, 90, 180, 270, 360. But what you're doing is you are using, and maybe I need to draw it here. Remember, for the parent function, y equals sine x. It was 0, 90, 180, 270, 360. and it went 0, 1, 0, negative 1, 0. Okay, that's what I'm using. And so then what I'm doing is I'm taking the y values and multiplying in this problem. I'm going to do this one, y equals negative 4 sine x. So 0 times negative 4 is 0. 1 times negative 4 is negative 4. This is 0. Now be careful. Negative 1 times negative 4 is positive 4. So I make 4 tick marks, label every other one. Now my y values are going 4 and negative 4. So here we go. I start at 0, 0, then at 90 degrees I'm down at negative 4. And think about this. This is a beautiful connection to even when we graph quadratic equations that have a shape of a parabola. Do you remember when you put a negative, instead of going up, it's reflected down. So that's really neat. And then the down is reflected up. So what I like to remember when I'm graphing the sine curve, it starts at the origin, and if it's negative, instead of going up, it goes down first. So look at my amplitude. It is still 1/2 the maximum minus the minimum. So amplitude will always be positive. So that's why the amplitude is 4 and not negative 4. All right, so amplitude. Amplitude is a vertical stretch or shrink. If there's a negative out front, that's a reflection. So now, I mentioned you can change the period length. So that's what we're going to do next. So if I have y equals, and I make it the sine of bx, the period length now is 360 degrees divided by b. So let's do one together. So I have y equals the sine of 3x. And maybe I'll go back up and just make sure that you understand that's inside the sine function. So remember, amplitude is the absolute value of the number out front. So my amplitude is 1, but my period length is 360 degrees. B is the number in front of x. So my period length is 120 degrees. Now watch this. This is what I do. Like, I don't actually make tables because I can do them for the most part just straight on the grid. So here's what I do. This is kind of an easy way to graph sine curves. If I know the period length, I make 4 ticks to the right and 4 ticks to the left. And I call the 4th tick mark what the period length is. So my period length is 120 degrees. So I count out to the 4th tick, call it 120. Then the 2nd tick is half of that. And if I wanted to know the 1st tick, think about it. What is the degree measure halfway between 0 and 60? Well, that would be 30. So I'm going to go on the other side, label the 2nd one negative 60, and the 4th one negative 20. Then I use my amplitude. My amplitude is 1. You have to remember that the sine curve starts at 0, and then it goes either up to A or down to A, depending on if the A value is negative. So ours is just 1. And then I'm going to follow the curve, continuing the pattern to the left. There I have it. All right, let's try another one together. Let's do y equals the sine of 1/2 x. So I'm not messing with the amplitude right now. So the amplitude is 1, because there's no number out front, so it's implied to be a 1. The period length is 360 degrees divided by the b value. Well, that's 1/2. If you recall, in Chapter 8, we worked with complex fractions. We had fractions within a fraction. Well, when you divide by a fraction, that's the same as multiplying by the reciprocal. Well, that's 720 degrees. So here's what you're going to do. You make 4 ticks to the right, call the 4th tick the period length. So I go to the 4th tick, call it 720 degrees. Take half of that, and that's going to give you the 2nd tick. That's 360 degrees. Label on the left side, and then my amplitude is 1. So the sine curve starts at the origin. Eventually we'll figure out left, right, up, down. But right now we're just doing the stretch and shrinks. So I'm going to start at 0, 0. It goes up to 1, 0, 0. Now I want you to think about it because this can be a little bit misleading how I'm having you do this. The curves look all the same, but in fact, if you look at this one, there's 720 degrees. There would be, in my other one, in this previous one, let me go back, there would be 6 cycles, okay? 6 cycles that would have been squeezed in here because it went 120, 120, 120, 120, okay? All right, now you try. I want you to graph y equals the sine of 4x. Please pause the video and see if you can find the amplitude period and sketch a graph. All right, so the amplitude is 1. The period is 360 divided by the b value. And what I mean by b value is this is y equals the sine of bx. It's what's in front of x. So my period length is 90 degrees. So I'm going to make 4 ticks to the right, call it 90 degrees. Think about what's halfway, that's 45 degrees. Now stop and think about this. What is the first tick? What's half of 45 degrees? That's 22.5 degrees, so you do have some yucky decimal there. So sine starts at 0, goes up to 1, 0, negative 1, 0. And then I continue the pattern. All right, we're going to try one more where we're just adjusting the period length. Then we're going to put amplitude and period change in at the same time. I'm trying to do this slowly for you, building your confidence. All right, so let's graph y equals the sine of x over 3. Now, what I told you is that we were looking at the sine of bx. The way that this is written, I have x over b. That's not actually x over b. So what you have to do is you have to rewrite this so that b is in front. So x over 3 is equivalent to 1/3 times x. So my amplitude is 1, and my period length is 360 divided by 1/3. So, when you divide by a fraction, you take 360 times 3 over 1, that's 1,080 degrees. So this is really, really stretching out a grid, but we're making 4 tick marks. Halfway is 540. All right, so this is 0, 0. Sine curve starts at 0. Eventually, we're going to graph cosine and tangent. And you follow your pattern. All right, so I just did 4 of these where we did not change the amplitude. The amplitude was 1 every time. And all we did was we adjusted the period length, which modified our x-axis. So now, let's put it together. So, if I have y equals a times the sine of bx, the amplitude is the absolute value of a, and the period length is 360 degrees divided by b. We're going to do 2 of these. Let's graph y equals 2 sine 3x. Again, we're going to graph y equals 2 sine 3x. So my amplitude is the absolute value of a. In this case, that's the absolute value of 2, which is 2. The period length is 360 degrees divided by b, and b is 3. So the period length is 120 degrees. This is really not bad, okay? This is very straightforward. So I'm going to make a coordinate grid, make 4 ticks to the right, call it the period length. So that's 120 degrees. Halfway, the second tick would be 60. Just go ahead and continue that on the left side. My amplitude is 2. So when I go to graph, the sine curve starts at the origin. Then it's going to go to the a value, not amplitude. Okay, I'm not saying amplitude. I'm talking about the a value. If it's positive 2, it goes up to 2. If a is negative 2, it's going to go down to negative 2. All right, so this goes up to 2 because it's positive, 0, negative 2, 0. I'm using those 5 main points. Those 5 main points. Those are critical to understand. And then you can verify that it does take 120 degrees to complete a cycle. You can see the amplitude is 1/2 2 minus negative 2, which is positive 2. If you're feeling confident, pause the video and try this one. All right, amplitude. The amplitude is the absolute value of negative 1/2, so it's a half. Now you might want to get in the habit of saying what A is. A and amplitude are not identical, okay? Not necessarily anyway. So amplitude is absolute value of A. The A value helps me to know whether I go up or down first. The period length. I'm uncomfortable with the way my equation is written because I don't have it as something times x. So I need to rewrite this. Okay, so anytime you have x over a number, you're going to want to rewrite it. So my period length will be 360 degrees divided by 1/2. So that's 360 times 2 over 1, or just 2. So that's 720 degrees. So I make 4 ticks to the right, 720 degrees. That means the second tick is 360. And you guys, you do know that sometimes I get going a little bit too quickly. If you feel as if I've gone too fast, you have a wonderful technology option. Pause it, rewind it. I strongly recommend, especially since this will not take up the entire class period, and you have the entire class period today, to take these notes, pause, rewind, or if you've been able to keep up but you still don't quite know what it means, go back and watch it again. Use every minute wisely in class. All right, so what I did is I made 1 tick for 1, and then I went to the halfway mark because my amplitude is 1/2. So I'm going to go 0, 0, but I'm going down 1/2. 0, 0, up 1/2, 0 again. So notice, can you tell it's a reflection and a vertical shrink? A reflection and a vertical shrink. There we go. All right, so what we learned today is how to graph the parent function for sine x, and then we looked at what the amplitude and the period, how those shift. In our next lesson, we're going to work on the left, right, up, down. So that's going to move things for us, and I'll take you through that nice and slowly in our next lesson together.